So all of the questions in this worksheet, all 6 questions, are relying on the fact that the definite integral is equal to the area under the curve, provided that f is continuous and non-negative. Now, one thing that I really want to emphasize, when you look at the definite integral, in this particular case, my variable of integration is x. And so when I write these bounds from a to b, this represents that x is equal to a, and this represents that x is equal to b. Now, you don't have to do this because it says on the worksheet that you can assume that f is greater than or equal to 0. But if you were to graph this particular function, you would have a parabola, and you would see that this parabola would be your x squared plus 3x curve, and then you would have x is equal to 0 to x is equal to 3. And those bounds are going to be the bounds for our definite integral. So we're going from 0 to 1, 2, 3. And so we are looking at, and again, we might have to expand this parabola up, but we are looking at the area that is between x is equal to 0, x is equal to 3. And the reason why they tell us this y is equal to 0 is because that is our x-axis. So it bounds us below. So it will be the area under the curve above the x-axis, and this is the area that we are trying to find. So I want you to kind of, when you're setting up these definite integrals, this will be your function, your integrand, and then your variable of integration is dx, but the bounds are always going to be x bounds because this describes x. So it'll go from 0 to 3. And then this y is equal to 0, that is just there to say that you're bounding it at the bottom by the x-axis. And just one quick note, in Calc 2, when you take calculus the second semester of it, oftentimes that's when you see what happens when it's not bounded by the x-axis, like maybe you have a line like x or y is equal to 2. But for now, it's always going to be the x-axis. So this, in many ways, is just understood, and you don't really have to think about what it means because that's your x-axis, okay? All right, so we are just going to integrate and then plug in the upper bound minus the lower bound using our fundamental theorem. So integrating, I add 1, and then divide by the new exponent. Here, I'll add 1, divide by the new exponent. And then 0 to 3 are my bounds. So I plug in, again, the upper bound minus the lower bound, and being careful that all of this lower bound gets subtracted off. So this will become 3 to the third over 3 plus 3 times 3 squared over 2 minus, and then all of the lower bounds subtracted off will be 0 cubed over 3 plus 3 times 0 squared over 2. Now, I always try to simplify as much as I can. So this 3 to the third is 27 over 3. So that is just going to give us 9 plus 27 over 2 cannot reduce. Minus, now inside of this bracket, it just happens to be that the 0 cubed over 3 is going to go to 0. The 3 times 0 squared, that goes to 0. So you have minus 0. All of this is going to 0. So that means those two terms completely drop out. So you are looking at 9 plus 27 over 2. So to get your one single fraction, you will add by getting a common denominator. So multiply it by 2 over 2 here. So you get 18 plus 27, and that will give you 45 over 2. And so that is the area under that curve between x is equal to 0 and x is equal to 3.